because we know that similar shapes are proportional, we can set up proportions to find missing side lengths if we're not given a scale, which is something we already are experts at. And notice we want corresponding side lengths to equal. So my right triangle and both these triangles are sitting in the same spot. So if I take 4, I'm going to put it over the corresponding side from our other triangle, which was 16. I'm going to set it equal to the 7 from the first triangle over its corresponding side, which was our x in the second triangle. So, first triangle, second triangle, first triangle, second triangle. Same side, same side. You have to make sure you set your proportions up correctly and don't get your numbers flipped around if you want to get the correct answer. And now, because we've worked with proportions in the past, we can simply solve this by cross multiplying. So 4x equals 16 times 7. 16 times 7 gets us 4x equals 112. And when we divide by 4 to both sides, we end up with x equals 28. So we can say that this side length is 28. Another way to do this is to notice that because the 4 and the 16 are on equivalent sides, 4 times what is 16? Well, I know 4 times 4 is 16. And I can do the same thing over here. 7 times the same proportion, same increase, times 4 will get us our x. 7 times 4, 28. So our missing side length was 28. Our next problem is asking us to find the new dimensions for the shape with a scale of 1 centimeter is 5 meters. And so we're going to set up a proportion. Short side, short side. Let's find that length first. They tell us that 1 centimeter is 5 meters. We're going to set that equal to our 2 centimeters, and we're going to figure out how many meters it is so we can label the short side of our purple rectangle. To solve, cross multiply. X equals 10. So we can say the short side of the purple rectangle is 10 meters. We can do the same thing with our long side of the purple rectangle. 1 centimeter over 5 meters, the scale they gave us, equals 6 centimeters of the short rectangle over x meters of our long rectangle. X equals 5 times 6, 30. So 30 meters. The dimensions of our purple rectangle, are 10 by 30 meters. And so we still set up proportions to find new dimensions, but we set it up where we had the scale equals the sides from our shapes. And notice how our labels, centimeters, straight across, we had centimeters. Meters, straight across, meters. Our labels matched, so we had it set up correctly. Now our problem asks us to find the new dimensions and perimeter for the shape to a scale of 1 inch is 5 feet. And remember, I always have been saying that our shapes need to be in the same, we need to view them the same. And so here we have the shortest side on the left side of the paper. That's not how this blue triangle is drawn. And so I'm going to redraw it. Pretend I flip my triangle and look at it so that it's sitting the same way as the triangle above. So I can call this side X, Y, Z, And I know that this will be the one with my x. This side correlates to y, and this side correlates to my z. Because my largest angle is in the same spot now when I look at them up and down. So let's set up our proportions. 1 inch over 5 feet equals 5 inches over x feet. Notice my labels, inch, inch, feet, feet. I have it set up correctly. X equals 25. So this side is 25. Next we have y. 1 inch, 5 feet equals 6 inches over y feet. And that gives us x equals 30. Or y equals 30, sorry. And our final side for z, 1 inch over 5 feet equals 9 inches over z feet. And this gives us z equals 45. So we have our dimensions, 25 by 30 by 45 feet. And then perimeter, remember, we add. So 25 plus 30 plus 45, 55, gives us an even 100 feet. So the side lengths are 25, 30, and 45 feet, and our total perimeter is an even 100 feet. The next problem says to find the new dimensions now and the area for the shape. And we have a scale of 1 millimeter is 5 centimeters. So remember, when we're finding the side lengths, it has to be to the corresponding ones. So here we have our short side. That is this side of our other rectangle. When I'm finding area of enlarged rectangles, I like to find the new dimensions and then find the area. It's a little more work, but it's a foolproof process, which is nice. So, set up a proportion. 1 millimeter is 5 centimeters, and we're given 2 millimeters. So, how many centimeters for our rectangle? Cross multiply, x equals 10. So, the short side of the green rectangle is 10 millimeters. Now let's find the long side, which in the orange one is 5 millimeters. 1 millimeter over 5 centimeters equals 5 millimeters over x centimeters. Cross multiply and you get x equals 25. So the long side of our rectangle is 25 millimeters. So its dimensions, nice and easy, 10 by 25 millimeters. But now we also have to find the area. And remember, area of a rectangle equals base times height. So we take 10 times 25 and we get 250, but we need a label. It was millimeter, and for area, you square it. So the area is 250 millimeters squared.